Hello, how are you? Everything is all right. Okay, I asked you to pin down your name in the comment box, and few people have also did it. They have commented. They have said that the video is nice and they appreciate my video. So thank you very much to them. And I am just showing those names and the comments over here in the video. So therefore, in my next video, I will do this. I will pin down your comment and also show your comment in my video in the beginning of my video. All right, let's get started. Alright, so from our previous discussion of Lagrangian and the way we have found out the Lagrangian, and I told you explicitly that why Lagrangian is important, why action is important, and we have to stationarize the action. So do you have any problem onto that kind of any discussing problem? So if you have any problem, please kindly specify me in my comment box and I will discuss, no doubt. So if you have if the picture is kind of clear, like, okay, why do we how to write the action. So what we are basically going to do in this video is that I'm going to take some problem and I'll try to solve it using Lagrangian physics. Okay, and with this I'm going to talk about the polar coordinate system, cylindrical polar coordinate system, and spherical polar coordinate system. Before jumping to quantum mechanics explicitly, I want to little bit deeper into to understand that what could be the application of Lagrangian, how can we apply the Lagrangian, and then I'm going to discuss Hamiltonian mechanics, right? Hamiltonian mechanics is why important, because again the quantum mechanics is too much deal with Hamiltonian framework. So if I have Lagrangian, then how we can go to Hamiltonian, and what could be the relationship between these two important framework can have, and how we can find the equation of motion. That is too much important. So that is what we are going to do in this video. So first of all, I am going to discuss some problem, how to solve them using Lagrangian, basically the application of Lagrangian. Then I will discuss in that with this problem I'm going to discuss the cylindrical polar coordinate system. There is actually polar coordinate system to solve the problem using circular symmetry, and if any particle is in disk and so on. Then we have a spherical system. So there are mainly three type of coordinate system. We have apart from the Eulerian Euclid coordinate system, you have x, y, z, everything is perpendicular to us, so on and so forth, and therefore we have these kind of systems, right? So first problem that I'm going to discuss, right, that comes with very important thing, that something is constrained to move. Let us say I have a pendulum equation, right? So here is a pendulum is in the rest position, and let's say I disturb it having some length L, right? And this is mass M. So how we can find the equation of motion using Lagrangian? So first of all, let us say what Newton has told us. Newtonian says that try to find out all the forces on this body and equate it to mass into acceleration, right? I know gravity is downside, and let's say that this is your x-axis and this is the y-axis, right? Over here, I say that our hinges, the clink is at 0, 0 position, all right? So from the rest, it is having some displacement that will make some kind of theta, and therefore in the x-axis, I can easily figure out what is the displacement, right? So therefore, I know how much this is. And this is L I have, and now this is the y displacement, correct? So either you can write your potential from here, that okay, how much displacement it has done from here, or you may just go through this one. So let us say that our position is 0, 0 over here. So I will, whatever the measurement I'm going to take, I will take from here. So for instance, first of all, this is the weight of the body. This is the string, therefore this is going to be a tension. And there is something, this is the force that is acting tangentially, because it's eventually is going to make in a circular kind of orbit, and this tangential force is applying over here, that is causing the mass to come to this position and then do the simple pendulum oscillation. So if you know the simple trick that if it is mg, let us say I have this coordinate system and some angle is, let us say this is your mg, this is the resultant, and this is x and y. I exactly know what is this, mg cos theta, and this guy is mg sin theta, right? So because this is the only force, this is basically mg sin theta, and this becomes mg cos theta. This mg sin theta is only there to respond for this acceleration to generate. Mg sin theta is equal to ma. And the tension that it feels, tension is equal to mg cos theta. I can easily know what is the angle in which it has been extrapolated, right? Or it has been disturbed. Therefore, sin theta over cos theta would becomes what? I can simply say sin theta over cos theta is tan theta and ma over t, right? But I know a is equal to g sin theta, isn't it? So either should I write g sin theta, or you know that. So the mass into acceleration over tension would give me the required angle, correct? And mg sin theta is equal to m into a. But you will ask that, okay, how do I know that this is basically a is equal to g sin theta is going to be oscillator system? Because in oscillating system, I have d2x over dt square is equal to minus k into x. If I have this differential equation, then I know this will give you eventually the solution a sine omega t plus, let us say, some kind of omega theta or omega t plus x, right? This will give you, this ensures me that this is the solution of simple pendulum and it's become oscillatory. So how do I know over here? So what I can just write here, a is equal to dv over dt, g sine theta. And dv over dt is what? Now I have to find what is the velocity, right? So how we can find the velocity? Therefore, I have to find out that what is the position that is we are trying to find out, right? Therefore, we have to understand that which thing is kind of responsible. Like, so the movement is in which direction? The movement is in x direction. So therefore, I will write x is equal to, so this position becomes what? And this position it will become, for instance, a is equal to g sine theta, and let's say that because this is what I am over here, and this is kind of circular arc, right? So I basically know this theta is equal to whatever this guy over here, theta is equal to some arc over, let us say some arc over this length, right? So theta is equal to this arc over length, and arc is equal to basically theta times L, isn't it? So whatever the velocity that will occurring, this velocity is also in this direction, right? So velocity is basically what? Velocity is basically, it says that, since it is very close to move in a circular direction because it has fixed length, and if it is trying to move, it will always make a circular path. Therefore, v is equal to r times omega, and this r is nothing but L. L is equal to d omega is basically d theta by dt. Why d theta? It says that how this angle is going to change, right? And L is fixed, there is no problem. Therefore, if I write dv over dt, it simply becomes d2 theta over dt squared. Hence, I know what is this one. I will write over here d2 theta over dt square is equal to g of sine theta. And from here, I can simply write d2 theta over dt is g by L sine theta. Now you see that, okay, in this simple harmonic motion, d2x over dt square is equal to minus k times x. Right? Displacement. But over here there is theta and there is sine theta. Then how we can find out? It's a little bit deviated. Well, we know what is the expansion of sine theta. Sine theta is basically theta minus theta cube over 3 factorial and so on. So let's say that I am assuming that if I have a simple pendulum, I have to give a little perturbation. This is the little change in angle. So theta is very close to 0, and in this limit, sine theta is basically 0, because if theta is extremely small or less than 1, any power would become decreasing, right? Like 0.1 cube basically 0.001, right? 0.001 or 0001. 1 by 1000, which is 0.001, yeah. Yes, sine theta out becomes theta. And therefore, I got d theta, d2 theta over dt square is equal to g by L. Sine theta is mainly tell you theta, right? So whenever I have this type of thing going on, it simply tells me that this is going to be your simple harmonic motion. It will show you the oscillatory behavior. And one may say that, okay, why A is equal to G sine theta? It has to be A is equal to G sine theta, right? Because the acceleration is always in this everywhere. Let us say that it is going like this, and when it will come over here, this will again go this one. Therefore, A has to be negative of whatever the force that is acting to it. Therefore, this guy is minus G sine theta, and therefore d theta over dt square is minus G by L. And this guy basically will give you omega square theta. And omega square is G by L. Omega is square root of G by L. I know omega is what? 2 pi over T is equal to square root of G by L. Let's make it inverse, and time period would become 2 pi under root L by G. This is the time period we have already calculated. So the important part over here, that is this guy. So if I apply Newtonian mechanics, I have to understand what are the forces that is acting towards it. I have to assume that, okay, which force is going to be responsible to accelerate system. So whenever I apply a force, the system is going to accelerate. But if the force that I'm applying is going to be countered by something, there would be no acceleration. That is what happens with T. I'm not getting any acceleration in the radial direction or in towards the length of the string. Or in which direction I'm seeing the acceleration, it is in tangential direction, the way the theta is basically changing. So it's basically making an arc, mg sine theta. And how we are related? Okay, I have to find that what could be the relation between this arc and this one. I know what is the L. This is the theta. Theta becomes arc by this one. So arc becomes theta times L, right? And I know the relation. Basically, this would become what? This becomes velocity. Velocity is what? R times omega, right? In the circular motion, velocity is R times omega, isn't it? So arc, you may just simply say that it is kind of a distance, theta times L, right? So this is how we have to think. First of all, I understand from the Newtonian mechanics, one thing is very clear. You have to understand the forces, right? But as I told you, we are not in a liberty that every time we can predict the forces. For instance, if you go to the particle mechanics part in a quantum world, there is no concept of forces, right? I don't know what type of forces is governing. So how we can understand, how we actually note down that, okay, how the particle is going to behave. And secondly, Newtonian mechanics doesn't tell you anything about that particle can even create. It says that it is never talking about any kind of annihilation and creation, right? It says that you just apply a force. There is a particle. How does it exist? Doesn't care about it. It has some kind of dynamics. But our understanding is that how this particle have emerged. If it has emerged, then what kind of mechanics it contains, isn't it? So when we are trying to delve deeper, then we have to go beyond something that is more important called action, right? And because of this, I told you that action is integral from two time period. This Lagrangian that is depending on position, velocity. If it is the system is closed, there is no time changing. I'm not writing any explicit time over here. I can ignore it. So in the more technical term, this coordinate is basically called generalized coordinate, and this will become generalized velocity. What is the meaning of generalized coordinate velocity? Because from problem to problem, I can adopt different coordinate system. And in different coordinate system, these coordinate can have different definitions. For instance, q can take theta. Q dot becomes theta dot. Theta dot is angular velocity, right? So it's not completely linear. So x dot, it simply said, okay, it is kind of linear one and so on and so forth. No, it is not. It has no. It doesn't have to, right? Now, I want to attack the same problem using Lagrangian mechanics. The definition of Lagrangian is, could you write the kinetic energy and potential energy for this system? Right? So here is my system. Okay. This is basically, this is 0, 0. This is y. Over here I have mass. And right now I have displaced it using some angle theta. I got this L and L. Right? So if this is your coordinate system, I have kinetic energy is half mv squared. I can use my vector notation to denote it. V square is a scalar quantity, but velocity times velocity I can write in terms of vector, right? So if velocity is a vector, it means that it has certain quantities in x direction as well as y direction. And where does this velocity come from? This velocity comes from the position vector. This position vector also can take two values if it is in two-dimensional space. Something is in x, something in y. So when I have disturbed this pendulum, this mass, it has gone some arbitrary direction. Therefore, from the origin, I understand that there is something in x direction and something in y direction. Right? So I have to define, first of all, this L is coincide with R vector. So let us just, for the moment, I am writing R vector as, what would be this one? I can use the Pythagoras theorem. I can certainly know x becomes L cos theta. Sorry, it has to be sine theta, right? L sine theta. And this would probably become L cos theta. Y become L cos theta. So this has to be sine theta is this guy over this L sine theta x hat L cos theta minus of y hat, right? Now L is not going to change. What would be the dr over dt? It simply tell me cos theta, theta dot. Whenever I am writing dot, any quantity that is over here over dot, it simply says dq over dt, right? Why I'm writing over dot, it's just a latex in a way of writing. Now there is no change in x hat and so on. I write now over here, I will write cos theta would be minus of sine theta and sine theta dot. Therefore, it becomes plus theta dot y hat. Therefore, I exactly know what's my velocity. And if I have to write a v dot dot v, I know these things, these guys only got contribution. Therefore, v vector square would become L cos square theta, theta square, L square sine square theta, theta square. Any problem so far? Any doubt? So everything is clear what I'm doing? Yeah, good. Now, I know theta square can be taken outside. L square theta dot square and cos square plus sine square theta would become 1. Therefore, v square is now L theta dot square. Therefore, kinetic energy would become m L square theta dot squared. Isn't it cool? Yeah, exactly, cool. Now, what would be the potential energy? I just simply told you the potential energy of this guy would be depending on y, right? That how much y is changing. So the potential energy is mg times the change y. Over here, my y is minus L cos theta. Therefore, I have mg is minus L cos theta. In which direction? Because it's a potential energy. I have already told you it is in y direction. So depending on theta, I told you that how much y it is. L cos theta, right? So if I know exactly what is my position vector, I certainly know what is going to be everything, right? Therefore, now since you have to understand something very important, this q and q dot, the coordinate and the velocity. So whenever you write t, which is usually, it can depend on q dot. Let's say I'm writing over here. It's also become q and q dot, because when you may just say, okay, you can only become dependent on only q, right? Coordinate, there should not be velocity. But you understand from the electrodynamics, F is equal to Q V cross B, right? V cross B. For the magnetic vector, magnetic forces, the potential energy can depend on velocity. Therefore, you should not, you cannot just write that, okay, the potential energy only depending on Q. No, it can also take velocity. It maybe all these quantities are time dependent. There is no problem. The Euler-Lagrange equation is not going to be affected. I will show you in the classical mechanics lecture. All right. Therefore, whenever you represent any kinetic energy, you must express everything in terms of Q and Q dot. Now, you understand over here why I am not writing X and X dot. Mind it, your Q is your generalized coordinate. Generalized coordinate. You see, when I am solving this problem, my X and Y notion has now converted into theta dot and theta. Therefore, you see that the Lagrangian is not just caring about that in which you have to be always restricted to some specific coordinate system. The coordinate system can keep on changing according to your plan, right? Therefore, I am writing Lagrangian is half m l squared theta dot square, and you would become mg l cos theta. This is the Lagrangian, isn't it? Now, when we have a specified Lagrangian, I have to find del L over del Q, right? Because what is the Euler-Lagrange equation? The Euler-Lagrange equation says del L over del Q d by dt del L over del Q dot. That will produce me 0. So, over here you have to define that what's your Q and Q dot. In this problem, the Q becomes theta and Q dot is theta dot. So, del L over del theta is simply, and I told you that this theta and theta dot is linearly independent. These are independent quantities, right? Hence, del theta dot over del theta have no contribution. It becomes 0. And I will get minus mgl sine theta. Similarly, I have del theta over del theta dot. It simply becomes ml square theta dot square. You have to use theta dot as a kind of object. I told you in the previous lecture. Any problem? So this becomes 2 theta dot. Hence, I got 2 and 2 will cancel out. This becomes theta dot, right? Now convert into Euler-Lagrange equation. It becomes minus mgl sine theta minus of d by dt ml squared theta dot. I know what's my L is constant, M is constant. There are two L's, one L is cancelled. Therefore, minus g sine theta minus L over here, theta double dot is equal to 0. So, do you believe me when I just told you? You don't have to do anything to get the equation of motion. And you already know what is the solution of this equation. Do you recognize this equation? Tell me please, honestly. Do you recognize this equation? It's magic, right? It's outstandingly magic because I just care what's my kinetic energy, what's the potential energy. I specified my coordinate accordingly. I got the solution, right? I didn't have to do anything. I told you that, coordinates are kind of very important. If you can specify what is the coordinate means that what could be the location of an object. If you exactly know what is the location of an object, you can do anything, whatever you want, isn't it? And that's why I told you that this guy is extremely important, right? So if you know the notion of vector, this is enough. If you can write it, your problem is already solved, isn't it? So that is the beauty. That is the beauty of the Lagrangian, that you don't have to understand what would be the free body diagram and so on and so forth. I don't care. What I just understand is that I have to write the kinetic energy. Kinetic energy has to be written in such a way that it has to be coordinate velocity, right? Coordinate time derivative. I'm not going to write, okay, well, this has to be velocity and it has to be omega. No, you don't have to write it. We will write it, but not now, right? So that is the most amazing thing about the Lagrangian mechanics, and that is why I want to, before diving deep into quantum mechanics, we have to, discuss these things. Because how we do understand that, okay, what is the power of this Lagrangian, what is the power of X, and aren't you just giving me some kind of, mathematical jumbo gumbo? No, I'm not, joking. Really. So if you have heard of it, you will understand, that, okay, what is, and if you haven't heard, you have already seen, you witnessed the interesting thing part. Now I'm giving a very important thing over here. First, I'm going to discuss the polar coordinate. Although this polar coordinate, you will find in my channel, right? I have already discussed this thing. So I'm just going over, very in a rapid pace, because if you just, can find it, they are early videos, like 5 years before video, you can just simply find out. Let us say this is a circle, right? In circle, I have xy. Any point at any instant of time, let us say there is coordinate, I know perfectly what is my x and y, correct? Now, I will change it because you already know when I use the polar coordinate system, there are two things, that is radius and angle, not x and y. So I have x is equal to r cos theta, y is equal to r sin theta. Because just make a perpendicular over here and you will know what is the components of x and y. All right. So let us say I have taken some kind of little displacement over here. Okay, this is the plane. So this displacement is, let us say, d theta, and I can also change the radius over here. So I'm like kind of, working in the generalized system right now. Let us say I can also go from here. So there would be some dr, isn't it? Right? Therefore, I can write down what is, because there is a relationship. R square is basically x square y square, isn't it? And also I will write what I can write, dr 2r dr becomes 2x dx plus 2y dy, isn't it? So there is a length element, that this is a circle, x and y, and let us say there is a length element I have to find. That in the polar coordinate system, how we can write the length element. So over here, there are two integral. So r can go to 0 to r, right? And theta will go from 0 to 2 pi. So forget about this thing. So I have just cut it out one piece, one slices. And this slice is, let us say, little bit of dr over here. That is dr. And at some specific r, there is a dr. And the angle is very small. There is a d theta. I can write down what is the line element of this one. Line element will basically care about this guy, this small piece, right? So this is dr, and hence this would become what? This is a curve, and from this situation I have theta, let us say it is d theta, and this is r, right? So this is basically what? D theta becomes arc over its length. So this guy, it becomes r d theta, right? So this is the square. A circle is now dividing at infinitesimal squares. How we can find the length element? The length element would become dr r hat. R hat means that you can change in this direction. Either you come backward or down or forward. Or this theta can only change over here in the increasing direction. This becomes your theta hat. There are two directions. In x, y, you have two orthogonal directions. Similarly, in r and theta, there are two orthogonal systems. Like r the hat and theta hat would become 0. All right. So one thing is that how your r changing. If you're in circle, there is no change in r right now. But if you're in disk, the r can change. And theta can always go in the increasing direction. This is how it's increasing, because I'm measuring theta from x-axis, right? Theta can go from 0 to 2 pi. So this will simply become, because there is a square it is taking, it becomes r d theta, theta hat. This is the construction of my position vector of infinitesimal coordinate. So what is the beauty? Let us say I am talking about circle. This dl would become 0 and r d theta theta hat, right? Well, if dl vector over dt r d theta over dt theta hat, and this becomes r theta dot theta hat. You see, if you compare it with this problem, same thing. R becomes L. Everything happens. Let us say this is, theta is changing, and because of theta, this guy will produce velocity. And in which direction? In theta angle direction, right? Theta is basically what? In this direction, right? So V would become R theta dot theta hat. Hence V square is R square theta dot square, right? But you have to also know that, okay, what is my basically x and y? So I already know what is the y, mg sine theta or cos theta it was. Mg sine theta maybe. Sorry, mg cos theta was. So for the velocity, if I know what is the length element, I don't have to, do anything. I will simply write over here that Lagrangian would become half m v square is r square theta dot square. So yeah, there is a time, when you will say that, okay, mg cos theta, let us say plus, how do I write the velocity? So if you know how to use some coordinate systems and you write the length element, it becomes really incredibly easy to find out the velocity, because if you know what is the velocity, then your half job is done. And the finding the potential energy is kind of very simple, because you have to just write what's your y, how the y is changing. Correct? The potential energy depends on the y, right? So this is kind of very incredible. Now, one thing I would like to discuss. Let's say that a particle is moving in a circle, isn't it? It's moving in a circle and there is no any influence. Let's say there is no potential energy, then what will happen? Well, L becomes half mr square theta dot square. This particle is moving in a circle having some fixed length, and it is very free. It does not have any kind of influence. When I'm talking about the potential energy, I told you that potential energy is basically doing some work done against some applied forces, right? That is how we think of it in terms of Newtonian, right? Or maybe some kind of interaction is going on between the particles. But classically, we say that, okay, we are doing some work against some kind of force. Therefore, the energy is going to be stored onto the object, right? Now, let's talk about the free particle. Free particle is basically free to move anywhere. It does not have any influence of any external agent, right? So consider a particle m is free to move in a circle. Good. A circle is shown over here, x and y. Immediately I see del L over del theta becomes 0. And this is incredibly great. You see over here, if I use the Euler Lagrange equation, I am going to write del L over del theta and del theta dot with the time derivative d by dt is equal to 0. Now you see, this guy is not there. D by dt, this del L over del theta is going to 0. What does it make it? It makes this guy constant. Because derivative only vanishes if the function becomes constant. Either function vanishes or becomes a constant, right? So if I just simply find it out del L over del theta dot, it will give me what? It will simply give you theta dot. If I write in terms of more familiar thing, theta dot becomes what? Omega, and for point particle, what is the moment of inertia? The moment of inertia is basically half m square or mr square or I mr square, right? Or half mr square. No, half is depending on the geometry. It's basically m into r square, I omega. And what's I omega? It's angular momentum. So I told you one very most fundamental thing is that if there is a particle which is free to move in a classical surface or any circular surface, the particle is classical, it is free to move, it's keep on moving and moving and moving, the angular momentum is going to be conserved. In which direction? In theta hat direction. No. Is it theta hat direction? Right now I'm not talking about theta hat direction. V is equal to R cross omega. It's in the y direction, right? It's in the plane. Let us say that x, y, and let us say x, y, and there is a z direction, right? If it is moving in this direction, it simply will feature the upward from the right hand rule, right? Because it's basically R cross omega, isn't it? So here I am not talking about, because I have to use the spherical system, but I'm not using that one. That's why I'm getting the problem from this theta hat and so on. But you see the incredible thing that it's not now the momentum, only linear momentum, because I told you that F is equal to ma, it's basically dp over dt. But now in this lecture, I understand that this dl over d theta becomes angular momentum. Therefore, d by dt of angular momentum is going to be 0. Angular momentum is conserved. That is the beauty. You don't have to think that what type of momentum is going to be conserved. It automatically come out as angular momentum. Right? That is the power of Lagrangian, isn't it? It's the beauty. When you are working with it, if you have figured out what could be the length element, infinitesimal length element, a job is done, right? Similarly, what is the extension of polar coordinate system? So there are ways to extend polar coordinate into cylindrical system. Cylindrical is again a pile of all the concentric cylinders. These cylinders, you will get the cylinder having some little z. Let's say these are my x and y, and there is z. Therefore, dl would become what? dr r hat. And this would I will like to write r d theta hat, and this basically dz z. If you have any particle, you can easily find out, compute the velocity. There will be no problem. And accordingly, you know what is your particle. Therefore, so in the coordinate system over here, this is basically what happens. Any particle is over here. This is r, and this guy over here is theta. This is your x and y. Understand how we have noted it. Similarly, little bit differently, but a spherical system. A spherical system is kind of very amazing. Why? Because there are 3 axes, we know it, indeed. But there is symmetry. Symmetry, it says that x square plus y square plus z square is equal to bigger r. The radius is going to be constant no matter where you go, right? So from here, what will I do? I will take, let us say the sphere is kind of solid one. It's not hollow. I can always take a slice, just the way I have done. So let us say there is a 2 type of movement. One movement is in xy plane. So for this guy, I can take, let us say this angle is called phi. All right. And for here, you may write rho, and you can take a projection that, okay, how if you go to z, because when z is equal to 0, this is the xy plane, right? So as you go up like a cylinder, we have done, you got from here, because this is what? Because something is in 3 dimensions. So 3 dimensions, how do we know what is 3 dimensions? So let us say this is x, y, and z. Something is over here. Therefore, how much it is in xy plane and what is in z direction, in z plane, right? So the actual position of this one are, so from here, from the z axis, it will make angle theta. All right. It will make angle theta. And how much it is, how we can find the projection in the xy plane? Just to make a perpendicular over here and connect a kind of vector, and this vector is called rho vector, which can be easily write down in terms of r and so on. And this angle will move in a circle. So over here I got phi. Phi would become 0 to 2 pi, and there is theta. Theta will always go from 0 to pi, 0 to only pi, 0 to pi, right? So, and dr, r is the radius, 0 to r. Therefore, in these circumstances, I can always write specifically what is, this is basically theta. So it would become r cos theta. This has now become r sin theta, right? And over here, I got rho, and I can say that, okay, this is my rho. So you may see that over here, this guy rho vector, this is how much there is in z, and this is the r actual position vector of this particle. So if I use the vector triangle law, this is the origin, I will write rho vector plus z vector is equal to r vector, right? So r vector would be eventually become rho vector, and I know what is g in this direction. It is basically r cos theta, right? And what is the rho vector? Rho vector would be how much is in x direction. So it will consist of something r rho cos phi x direction, rho sin phi in y direction, and r cos theta. That will eventually become r vector. Now there is, again, you have to take the dr limit and so on, and you have to try to solve it, and there is some kind of transformation. You can see my other video. I will post a link. But in this case, the dr vector would become dr r hat, r d theta theta hat, same polar. But here eventually there is something you will get, r sin theta d phi phi hat, and you exactly know what is the limit. Okay, and what is the, so this is it, right? And do you know what is the formula for volume? 4/3 pi r cube. I exactly know what is the length element. Let me just write over here dl. V would become what? All the coordinate dr, just multiply everything, right? Dr into r d theta into r sin theta d phi. If you don't know how to do the integral, you can just see my multivariable calculus video. What I can do, it becomes a triple integral. It's called a multivariable calculus. So all these becomes r independent. Like I can write dr into r, it becomes 0 to r. Sin theta d theta, it will simply become 0 to pi, and d phi will become 0 to 2 pi. It's simply r square by 2. Sin theta would give me minus of cos theta, right? Minus of cos theta, 0 to pi and 2 pi. Oh, sorry, there is r square. So it simply becomes r cube by 3. So 2 pi r cube by 3 cos minus theta. So cos of pi would become 1, and cos of 0 is minus 1 minus 1. Minus 1 is minus 2 plus 2, 4 pi r cube by 3. You see, if I know dl length element, the volume is easy. And similarly, you can find the area. Just use these two things. In area, there is surface area, right? So I don't have any variation in dr. Fix r to r. Multiply these two guys. You know what is the limit. It's not going to be changed. And you will probably get the area. And area would simply becomes 4 pi r squared. So this is the one of the important thing that I would like to discuss these things. So what you can simply do, I cannot take too many examples of Lagrangian because of time constraint. I assume that this lecture is too fascinating, but I'm just giving you one more aspect, that how we can find the Hamiltonian. Hamiltonian is again simple. I said that dl will produce me 0, right? Isn't it? Because if I say that the system is closed, there is no influence on the system from outside, then it's going to be okay, right? There would be no problem. Well, I know this becomes q and q dot. Therefore, dl by dt would simply mean dl over dq and dq by dt. This is how we take, if you have already done take the partial derivative classes, or maybe if you have done something related to with thermodynamics. In thermodynamics there are a lot of partial derivatives and you have to do all this to derive the Maxwell equations. You already know, but I will make video if you don't know, right? It is the chain rule. Now what you can simply get, dl over del q, and dq becomes dq dot, and over here I got del L over del Q dot, and this is dq dot over dt, right? I have Euler Lagrange equation that says del L over del Q is basically del L over del Q dot, and take a time derivative, vanishes. Fine. Now I can do over here is simple. I write del L over del Q as, it becomes go to 0, therefore it will pick a positive sign. Del L over del Q dot, there is Q dot, plus del L over del Q dot and dq dot over dt. Any problem? Now why I have done this guy, you see there is something over here. This is dq dot by dt, and this is del L or del LQ by del t. So I somehow write d by dt of del L over del Q dot, just make complete time derivative, and there is Q dot, right? If I do so, what will I get? I will first get del L over del Q dot with d by dt, and there is Q dot, right? And another case I will get del Q dot, and this is becomes Q double dot. I have got something, right? dl by dt, Q dot, and this guy. Wow, it's incredible. Q dot and Q, and this is dl over dt, right? Now the magic is that left hand side, d by dt, full derivative of Lagrangian. This side over here, the same thing. I will say d by dt L minus dl over del Q dot is equal to 0. Now I told you that this is del L over del Q dot is what? It becomes momenta. Momenta is what? A generalized momentum. Hence I can simply write L minus P Q dot is equal to 0. I told you right away, just a little bit before, any quantity whose time derivative, full time derivative is going to vanish will give you 0. This guy becomes constant. Now the question is that what is this guy? Wait a second, I'll tell you in a minute. Let's say I have kinetic energy minus potential energy. Strictly speaking, making things clear, writing this way, right? So Lagrangian is, I write PQ. I don't know what it will give me. T minus U, and if I say del L over del Q dot would simply kinetic energy what? Half mq dot square, right? It will simply mq dot, correct? So this one, and take a derivative of del Q dot would give me mq dot, right? So P would become mq dot Q dot. T minus U minus mq dot square, I can write half mq dot square as Q dot square, mq square, there is half. So I will write multiply by 2 into 2. This becomes 2t. If I take common, what you got? I got something. I got something incredible. I got that this L minus P Q dot is basically total energy, and this guy would become Hamiltonian. you see that I didn't have any concept of total energy being conserved of the system. Because total energy is there, people have said that in universe, total energy is going to be conserved. But in the Lagrangian concept, I got kinetic energy and potential energy. There is no way I had something called that, okay, there is a concept of total energy, right? Total energy conserved or not, it's a different issue. So I just said that my system is closed. There is no influence of any time quantity. I told you that, can I write the Lagrangian for it? Yes. Can I take the time derivative? Yeah, I know. I just took a time derivative, dl over del t is equal to 0. And since the system is closed, I exactly know, sorry, not this one. I exactly know that there is no explicit time dependence in the Lagrangian. It's going to be 0, right? If I just consider that one, using the kinetic energy half mq dot square, because that is the definition that I'm going to follow, I'm going to adopt. I found out that this is u plus t, and u plus t is what? I know it's total energy. And in this case, I can define total energy as the Hamiltonian. Hence, the Hamiltonian is defined as pq dot minus Lagrangian. So, for one particle, this one, I can always write for any particle pk qk dot minus L of k. Or write, yeah, L of k, Lagrangian of those particles. Isn't it beautiful? And if you assume that, okay, fine, so therefore, you see from here, I got something incredible. This is pk and qk. Therefore, h has now become the function of p and q. This is called generalized momentum. This is called generalized velocity. Sorry about that. And I can simply say, okay, I take dh, right? dh would become del h over del p dp del h over del q dq. Okay, any problem? No. Let's say, because I know this dh over dt is again going to be constant, right? There is no issue. dh over dt is simply become del h over del p dp over dt del h over del q dq by dt, right? No problem. Now over here, can I do something? You may just say that, okay, what you want to do? I also want to take the h dh over here. I will say, no, not this one. Like I will write p q dot plus p dq dot minus d Lagrangian. All right. So as we have defined our Hamiltonian, what we can simply do over here is that we can take again, as Hamiltonian becomes the function of p and q, you can also write it that explicitly it can take time t, right? So let's derive some particular relationship, that what could be its momentum and coordinate, or maybe there is some kind of basically equation of motion, right? How we can find the equation of motion? If I have certain, system, certain definitions, right? I have a h. Euler-Lagrange equation is a definition. If you have written the Lagrangian for any particular system, you have Euler-Lagrange equation, and from there you can find the equation of motion. You have also do the same thing using Hamiltonian. You got Hamiltonian, write it in terms of like this, or you may see, you have already seen that h would simply become kinetic energy plus potential energy. This is the definition of h, right? Once you know what's your kinetic energy and potential energy in terms of p and q, you have to write it. But the question that asks that, is there any Euler-Lagrange equation if I am writing the Hamiltonian? Yes, that's what we are driving. And for that, what I'm going to do, I am first writing the total derivative of dh right away. Now, instead of writing dh over dt and so on, what I'm going to do, I will again go back to this one, right? Dropping all the indices, I'm writing dh is dq q dot p dq dot and minus dl by dt. And you know something that I can write dl as dl by del q dq plus del L over del Q dot dq dot, right? Or maybe you may write that, okay, I am very much fond of dl by dt, no problem. You can just write whatever you want. So I got dpq dot plus p dq dot minus, now what is del L over del Q dot? Wait, I have to be very clever right now. Del L over del Q dq minus dl by del Q is what? That is our momentum. Momentum that we call it dq dot minus del Lagrangian over del t, isn't it? Now you see p dq dot is going to be cancelled out each other, and I got something q dot dp minus dl over del q dq minus dl over dt, and this is I got dh. Now you see that what is the advantage of doing this one? There is an advantage. The advantage of removing that guy is reside over here. If you will probably see, there is dp over here, and when I'm taking this guy right over here, I got dp. This is my dq, I got dq, right? And it's incredible. Therefore, I can simply say that q dot would become dh over dp, and dq, what is del L over del q? It simply becomes minus p dot dq, right? So this dh over dq del q is p dot. Now these guys are basically coming from Euler-Lagrange equation. So I have used the Lagrangian with Euler-Lagrange equation to find the equation of motion in Hamiltonian dynamics. It simply says that if you have written the Hamiltonian, you can easily get the equation of motion. What you simply have to do is that if you take a derivative and take a derivative with respect to p, I am going to get the velocity, generalized velocity. If I take a derivative of h with respect to q, I am going to get the generalized momentum derivative, right? And this moment derivative could be forces and could be anything. This is called generalized forces, right? So how we can simply comprehend, I will write h is equal to t plus u. T is what? Half m q dot square, right? Now for a moment, I told you that h depends on p and q. Therefore, I have to do something to remove this q dot, because there is no q dot right away. So that is the momentum. Momentum is what? Momentum is p into q dot. So I will use 1 by 2m, m square q dot square. It becomes p square by 2m, correct? And u is simply become a potential dependent. Let us say mg into q, correct? So let me just write it over here. P square by 2m plus mg into q h, isn't it? Now, what you have to do over here, I am going to take del h over del p. Del h over del p becomes what? P by m. And what about del h over del q? Del h over del q is basically mg. Now you will see that, okay, what you are doing? I'm telling you that, okay, I'm doing correctly, because del h over del p is what? It simply give you q dot. And del h over del q is what? Minus p dot. Right? So it simply tells me that, q dot is p by m, right? And if I write q double dot, it simply becomes p dot by m. Q double dot is what? Is simply, you can write d2x over dt square, right? And let us say, what is my p dot? P dot is minus m into g over m. It simply says that your acceleration, if it is falling, sorry, dt square, d2x over dt square is minus g. It's nothing but a is equal to minus g. I told you that any particle that is free to move under free fall condition, it is a particle mass m, it has certain kinetic energy and certain potential energy that is given by mg something, right? Mgq. This is what you can write. So what would be the acceleration? Acceleration is a is equal to minus c. This is what you have found, d to x. And the thing is that I told you what is the goal. The goal is to find the dynamics. And dynamics is over here. I know what is my velocity. Velocity becomes p by m, linear momentum. And what is the generalized force? Generalized force is basically minus p dot. What is the derivative of p dot? P dot becomes m into g. Isn't it great? Exactly, it is great. So that's why this is called as the equation of motion when we are doing the Hamiltonian. This is how we can find it out. And something really, another thing we can do is that, what about this guy? Well, I can take it. I can simply say that, okay, dh over ds, and therefore I can take dh over dt. So, right. Yeah, you may simply say this one as ds. Let's say I told you right over here. I have taken dh, right? dh is equal to, I can also write dh over del t. So you may see it simply becomes del h over del t is equal to minus, is it partial or full derivative? It's partial derivative. My del Lagrangian over del t. So no matter where you have started, either you writing Lagrangian, I can easily construct Hamiltonian. And from here, I can find what is generalized velocity and generalized forces, maybe p dot, or I know what is my generalized momentum because I have started my Lagrangian, and I can find out what is the Lagrangian, what is again p dot there, because del n over del q is equal to d by dt of p dot. Both are equivalent. But if you will study general relativity, in quantum mechanics, we adopt Hamiltonian mechanics, Hamiltonian mechanism, right? Both have not the same structure when we are writing. But in quantum field theory, we again go back to Lagrangian formulation. In general relativity, we adopt more Lagrangian formulation instead of the Hamiltonian. So in classical mechanics, when we are seeing the action, so the most fundamental thing is the action, right? So if I have constructed the action in such a way, I can easily find the equation of motion. And according to the problem, according to the physics that you want to devise, you can use the tools the way you want. So I'm going to talk more about it. So in this lecture, we have finished Lagrangian, problem of the Lagrangian. What is the coolest thing in the Lagrangian? I have left the symmetry intentionally because I'm going to discuss in the classical mechanics chapter and discuss the Hamiltonian part. That is the most important part. That would be the founding thing to study quantum mechanics. So in the later video, I am going to give you the drawback, or mainly I'm talking about a theoretical framework. I'm not give you any experimental kind of thing. I will just give you one experiment. Okay, this and this and this happened. But more, I will focus on the theoretical structure. That I have now Lagrangian in my bucket, Hamiltonian. How we can formulate quantum formulation from here. So for the time being, I'm leaving you with my video. Please see my other videos and kindly pin down your name in the comment box. And I will post your comment in my later video and answer your any query you have. So I'm assuming that you have no more problem right now, or whatever is the problem you have, we can discuss in the next video. This is Saddam Cap signing out.